So the ACE experiments are working really well. The experiments that we did forward BCAT allow us to look macroscopically at changes in samples. So we'd be pulled way back in a sense. We look at the bulk changes and things. We look at how they begin to evolve and separate, but we'd see things from a distance in a sense. The ACE experiments instead allow us to focus in on the microscopic changes. We have functionally a magnifying glass. We are able to see all the colloids in the system, all those small particulates and how they move, and we can correlate all those motions and those times back to the macroscopic samples and changes that we saw previously. And that's great. It allows us to connect theory. It allows us to connect all the things that we might think on the microscopic level to the bulk changes that we see. The reason I want to fly in the KC-135 is just really fundamental to the science that we're doing. Before we start all the experiments, the astronauts have to stir our samples. And there's about a couple, 3, 4, 5 hour delay between when the samples are stirred and when we take data. So two things can happen there. One, we don't really understand whether our samples are stirred properly. And so this will give us insight as to whether that's done. Give them an operating procedure to do that correctly. And it also gives us an opportunity to watch the samples evolve within those that time window between then and when we can actually take data on ACE. All the research that I have seen to date also just deals with systems of particular size materials. We developed a lot of good theories. We developed something about how they behave thermodynamically, how they behave kinetically. When we start making these mixtures, the materials that we see, they behave very, very differently, somewhat unanticipated, I think, very unanticipated. And I think that's going to change not only science, but it's also going to change the way that we develop our industry as well.
Understanding the science behind our products is absolutely critical. It leads us to new discoveries and new innovations. We use this fundamental understanding to improve product stability, make the benefits that we have more consumer noticeable. We use it to compact our products to generate less waste, smaller bottles, less water, less things to ship around the world. It's having that fundamental understanding that really guides us to the critical choices on ingredients in our products that drive those benefits.
It's a little early yet, but I would say that the products that we're working against, the ones that we're thinking about applying the science to, each of them are worth about $1 billion. So that's a significant amount of money. If making new products that help people or savings off products that we have, I think the dollars are going to be really significant.
Product design is really about designing the juice that goes in the bottle. It's all about designing a product that's going to be stable on the shelf for weeks, months, or even years, but then the product that'll spring into action when the consumer uses it and delivers a benefit that'll make them come back and buy our products again.
From a company's perspective, there is a lot of competitors. There are a lot of people trying to make better products. I think they look at science and say that science is fundamental to our ability to innovate new products. And to stay ahead in the marketplace is to make better products with innovation with the science. It's as simple as that.